Hi everybody, and welcome back. We are starting a new chapter here. So we've talked about the regular 6 trigonometric functions, and now we're going to be talking about their inverses, or the functions we call inverse trigonometric functions. Now, if you remember, inverse, if a function has an inverse, that means when you compose them in either direction, then you get back what you started with. And I think you may remember that not all functions have inverses. And in fact, if you look at the graph of, let's say, the sine x, okay, this definitely does not pass the horizontal line test, right? If you take, for example, there are several, for this horizontal line, there are several points of intersection, okay? So the sine x is not, doesn't have an inverse. However, if you restrict it, to a certain interval, like maybe from here to here, or from like here to here, it would have it would pass the horizontal line test, and we can just say that that part has an inverse. Okay. So just remember that we denote if f is a function and f inverse is its inverse, we have the property that f of f inverse of x is always going to be equal to x for when this makes sense, and f inverse of f of x is equal to x. Okay, so that's what we mean by inverses of functions. We're not talking about reciprocals. So going back to this, probably the best way to start is to look at the unit circle. And if we pick any point on the y-axis, any value, we'll call it x, even though it's on the y-axis. So if x is any number between -1 and 1, then there's going to be exactly one point on this semicircle where the y-coordinate is equal to x. Okay, and that point determines a unique angle, and so the sine of this angle is going to be equal to x. Sine of theta is going to be equal to x. Similarly, if we look over here, if we let x be any point on the x-axis from -1 to 1, there's going to be exactly one point on this upper semicircle in which the x-coordinate is equal to x. And that point determines an angle theta, and we can see that the cosine of theta, this angle, is going to be equal to x. Okay. So now we're going back in the other direction, right? If we start with a number between 1 and -1, we'd like to find an angle whose either sine or cosine is equal to that number. Now there's lots of numbers that would work, right? We could have we could add 2 pi radians to this, or as many resolutions as we want, and that would we get another solution, another angle whose sine is equal to x. But we only want, if we restrict our to a certain range, like -pi/2 to pi/2, then there's only one. And similarly, if we restrict our theta to be between 0 and pi, then there's only one value of theta, where the cosine of theta is equal to x. So we do the following. So if x is a number between -1 and 1, we define this function inverse sine x. That looks like sine to the -1 of x. We call it inverse sine of x, and we just define that to be the unique angle theta, or the unique number theta, between pi/2 and -pi/2 and pi/2, such that the sine of theta is equal to x. And in some textbooks, they also call this the arc sine. I kind of like this better because it actually reminds you what it is. It's the arc whose sine is x. But most courses and books use this notation. Similarly, this expression is called the inverse cosine of x, and this is the unique angle or number theta between 0 and pi, such that the cosine of theta is equal to x, and we call this the arc cosine. In some cases, we call it the arc cosine, or read it the arc whose cosine is x. The important thing is when people get this, the notation is unfortunate, because Usually we say, okay, negative, this is how you interpret negative exponents. But this minus 1 here is, we're talking about the inverse of a function with respect to composition, not multiplication. So the inverse sine of x is not the same as 1 over sine x. Remember, this already, we have a name for this. This is the cosecant of x. So this is different. These are two totally different functions. Likewise, the inverse cosine of x is not to be confused with the secant of x, which is what this is. So keep that in mind. A very quick way to remember this is if y is equal to the inverse sine of x, that means two things. That means the sine of y is equal to x, and y has to be in between negative pi over 2 and pi over 2. If y is the inverse cosine of x, that's the same thing as saying that the cosine of y is equal to x, and that y is between 0 and pi. So right now, if we were to consider this as a function, this as a function of x, we can see the domain is going to be all numbers between negative 1 and 1, and the range is going to be all numbers between negative pi over 2 and pi over 2. So that would be the range of inverse sine of x. Likewise, the domain of inverse cosine of x, if we look at this as a function, the domain would be between all numbers between negative 1 and 1, and the range would be all numbers between 0 and pi. Okay, so let's try to start and figure out what some of these set values are. So let's look at the first example, inverse sine of 0. What we're really asking is the sine of what angle is equal to 0. And we know that there are several angles that will work, but only one of them will be between negative pi over 2 and pi over 2. And going up here, we can see that, when x is 0, that corresponds to this point, and the angle is 0. So this is just going to be 0, and that the way to double check is that the sine of 0 is 0. Question is, what's the inverse sine of 1/2? Okay, well, you ask, sine of what angle is equal to 1/2? Once again, you can go up to your unit circle here and say if x was 1/2, all right, well, what angle in the first quadrant has a sine equal to 1/2? Well, if you recall, if you have your unit circle in front of you, that's great. But remember, here's 30, here's 45, and here's 60 degrees. The sine of 30 degrees, well, remember the coordinate here, we don't care about the x coordinate. Well, the y coordinate will be 1/2, okay, for 30 degrees. And that's exactly, remember, this is 30 degrees, but we want to use everything is in radians with these functions. So we need to convert this to pi over 6, okay? And so the inverse sine of 1/2 is pi over 6. What's the inverse sine of square root 2 over 2? Well, again, we can see that would be the next one. Here's square root 2 over 2. That's 45 degrees, and remember 45 degrees is equal to pi over 4. So this would be pi over 4. Okay, because again, you can check that the sine of pi over 4 is equal to square root 2 over 2. Okay, and I should say maybe over here, this is pi over 6. Okay. What about the sine of negative square root 3 over 2? Well, that is going to be down here. It's going to be all the way down here. Remember, it's the last one, lowest one down here before you get to the axis. So this is negative square root 3 over 2. Okay, and this would be negative 60 degrees, but that's the same thing as negative pi over 3. Again, on your unit circle, I think they might have listed this angle as 5 pi over 3, but 5 pi over 3 is not between negative pi over 2 and pi over 2. So we've got to keep that in mind. So the answer to this would be negative pi over 3. Okay, because the sine of negative pi over 3 is negative square root 3 over 2. Well, what would the cosine? Now let's look at the inverse cosine. The inverse cosine of 1. Well, what is that? Well, we ask what cosine of what number is equal to 1. And I think you can remember that over here it would be when the x-coordinate is 1, okay, the angle is 0, okay, so this is just going to be 0 because the cosine of 0 is 1. When is the cosine of what number is equal to negative square root 2 over 2? Well, if the x-coordinate is negative square root 2 over 2, we're in the third quadrant here. And you can look back on your chart and see that this is 3 pi over 4. 3 pi over 4. So this would be 3 pi over 4. Okay. And the cosine, the inverse cosine of square root 3 over 2, that would be, okay, so where the x-coordinate is square root 3 over 2, that would be this, 30 degrees, or pi over 6. So this is pi over 6. And the inverse cosine of 0, well, cosine of what angle is 0? Well, it's going to be up here, because when the x-coordinate is 0, we're up here, and that corresponds to pi over 2. So this would be pi over 2. Okay. So we're just sort of using our knowledge of the unit circle and these values that we've memorized. Okay. So let's look at some more examples over here on the next sheet. Okay, what angle has in the sine equal to 1? Well, I think you can remember we were just talking about that angle. It's pi over 2, right? Because the sine of pi over 2 is 1. The inverse sine of negative 1, what do you think that would be? Well, we know with sine, when the y-coordinate is negative 1, we're down here. Okay. And our chart says it's 3 pi over 2, but we want to go in the correct range. So it's this angle here from negative pi over 2. Okay. The sine of negative 1/2, okay, if you remember, that is going to be in this fourth quadrant here, and you can check that that's going to be negative pi over 6. Okay, that's the y value. The inverse cosine of negative 1, you can check when the x-coordinate is negative 1, we're over here, that corresponds to 180 degrees or pi. And remember, we never write the answer to these values as in degrees. We always use radians. The inverse cosine of 1/2, you can check that is going to be pi over 3, because that's 60 degrees. The inverse cosine of 2, there's no angle whose cosine is 2, right? The cosine has to be between negative 1 and 1. That's the domain. So this number, whatever this number is in here, has to be between negative 1 and 1. And if it's not, then this is undefined, or it does not exist. Similarly, there's no angle whose sine is negative 3, so that's also undefined. Okay, and then of course you could get an angle, asked to find the value of inverse sine of something which is not on the unit circle. So we just have to use our calculator. Okay, and when you do this, on whatever calculator you have, you want to make sure that you're in degree mode, the right mode. So should we turn the calculator on and go just check on mode, and here we are indeed in radian mode, so that's good. So now we can just take the inverse, hit the inverse sine button, inverse sine of, in this case, 0.68, 678, and that's 0.745. Okay. All right, now, these next statements here are just a kind of a reflection of what we already know. This all kind of goes back to the whole idea of inverses of functions. So the sine of the inverse sine of x is x for all x, as long as x is between -1 and 1. Now, why is this? Because this is almost so easy it's hard. Okay, if I ask you what is the sine of the angle whose sine is x, if you think about it for a moment, it has to be x, right? Because this number here, you might not know what the value of this is, but you know what sine is. The one thing you know about this number is sine is x. Okay, so it's x. Similarly, the inverse sine of the sine of x is equal to x as long as x is in the range. All right, because we're saying that x is the inverse sine of something. The only way that can happen is if x is in between -pi/2 and pi/2. So this is true not for all x, but x has to be between -pi/2 and pi/2. And then the cosine of the inverse cosine of x, once again, this has to be x for all x greater than or equal to between -1 and 1, because we said this angle has cosine of 1. So the cosine of this angle is x, so cosine of this angle is x. And then similarly, the inverse cosine of a cosine of x is x as long as x is in this range, because that's the range of the inverse cosine. Okay, so right away we can see like the square root 3/2 is certainly between -1 and 1, so this will be square root 3/2. Cosine of the inverse cosine of 1/5, that's 1/5. Okay. This sine of the inverse sine of 2/9, that's going to be 2/9. Okay. So that's not too hard. Okay. As long as I didn't give you something like the sine of the inverse sine of 11. Okay, then that would be undefined. Now, what about the inverse sine of the sine of pi/7? Pi/7 is between -pi/2 and pi/2, so this is just pi/7. Okay. The inverse sine of the sine of pi/8. Well, pi/8 is not in this range. Okay, it's in fact pi/8. If you look over here, pi/8 is going to be a little more than pi, so it's in the third quadrant. Okay, so if this is 9pi/8. Okay, so what the actual point we want is this point right here, because we want the y coordinates to be the sine to be the same. That means so we want a point on the unit circle with the same y coordinate. So actually, the inverse sine that we're looking for is this angle, right? And because from here to here is pi, and from here to here is we're going in this direction pi/8 units. So this direction is pi/8 units, but we're going in the opposite direction, so this is minus pi/8. Okay, so this is actually going to be negative pi/8. Okay, so you want this to be in the correct range. The inverse cosine of 3pi/4. 3pi/4 is 3 pi divided by 14. I should say this number is between 0 and pi/2. So this is just going to be 3 pi. Actually, it's going to be between 0 and pi. So this is going to be just 3 pi/14. So that's fine. The inverse cosine of negative 3 pi/14. Well, the inverse cosine of anything can't be negative. We can't say this is a negative number because it has to be between 0 and pi. So it's actually, we need to find a number, and because we know that the cosine of negative 3 pi/14 is equal to the cosine of 3 pi/14, okay, because remember, sine is an even function, right? So the angle that we want will be just 3 pi/14. So this is 3 pi/14. And then the inverse cosine of the cosine of 14 pi/3. 14 pi/3 is not in the range, right? but we know that 14 pi over 3 is the same thing as 12 pi over 3 plus 2 pi over 3. Okay, and so we know that the cosine of 14 pi over 3 is going to be, well, this is the cosine of 4 pi plus 2 pi over 3. Okay, and if you add a multiple of 2 pi to anything, it doesn't change. So this is actually going to be equal to the cosine of 2 pi over 3. And that will work, right? That is in 2 pi over 3 is in the range. So this is actually 2 pi over 3. Okay. All right. A lot to go over here. Okay. If this is the first time you've seen this, there are a lot more problems in the book, in your homework. So that concludes the first half of this section. We'll come back and we'll talk about the inverse tangent in the next video.